please ask your questions right now, but the questions will only be answered at the end of the presentation. So again, it's going to be answered in about 1 hour. Okay, so we have about 9 participants in the webinar right now, and I'm going to start right away. So this is the main Automation Studio interface. When you open up the software, these are, of course, the toolbars. And we have here the Library Explorer. And on the left and on the right, you have the Project Explorer. Now, the Library Explorer is used to pick components. So if you click on the branch, so these are the branches that you have purchased. Right now, I have the full license, so all the workshops are showing. But depending to your license that you have purchased, you may have a different listing of the workshop. The presentation of today is going to be done mostly in hydraulic. So for the basic is almost the same for all the other workshops. We will do a bit of ladder logics and a few electrical control diagrams just for getting familiar with the different variable assignments that we have into Automation Studio. So for the first circuit, I would like to start with the basic hydraulic diagram. So first of all, you have to open up the Library Explorer. Once it's done, it can also be accessed by the book with the magnifier right here. So this is the Library Explorer, and the one on the side is what we call the Project Explorer. So in the Project Explorer, you can see that you have different diagrams listed, and the folders are projects. So if you compare this to any workbook like you have like in Excel, the project is the workbook, and that workbook contains many worksheets. So it's the same in Automation Studio. You have a folder, which is your project, and this project file contains many diagrams. Right now we only have one. So into the diagram that I have right here, this is regular. If I right-click to view the document properties, you can see that I am now on a diagram size standard, which is 8.5 by 11. I'm onto the portrait orientation, and then this is exactly the page size that I have, and this is my drawing surface. So first I'm going to zoom to the page by clicking on the icon here, zoom to page, and then I'm going to drag and drop my components. By the way, if you have any problems seeing the components here on the left, what you can do is you can right-click in the blank, and you can then decide which kind of which size you want to see the icons. At any time, if you're moving over one of these icons, you will see a bigger preview anyway. So if you have difficulty seeing the actual component, when you're moving over the component, you can see a bigger preview of it. So I prefer working at a medium size, no problem, but again, it's really up to you. So I'm just going to drag and drop components. Before I will do, actually, there's something that's really important to use. By default, it's activated, but just in case, you might want to make sure that if you go into the View menu, you will see that the Components now is active, and as well as the grid is usually a good thing to have. So you can activate the grid by the View menu, or as well as by using the toolbar right here. Okay, so by default, I prefer using the grid and as well to have the components now. All the symbols, or almost all the symbols, are done using the ISO standard 1219-1. So the ISO standard 1219-1 works onto a 2mm grid. So if you zoom in, you will see that there's a grid right now. I'm just going to make sure that you can see this grid by going into the grid properties, into the View menu, and by changing its regular pale gray color into a black dark color. Okay, so this way it's going to be easier to see that there's a grid right there. So now all the components are made into a 2mm grid, so every time you drag and drop a component, it's connection ports, and what we call connection ports is these red circles over here. These red circles will fit onto the grid. So when you're dragging and dropping components, you'll be sure that everything will be aligned and straight up, and it will look nice at the end. Okay? So I'm just going to complete the circuit right now. I'm just going to zoom out. I have a key function that I'm using right now on the keyboard. It's the control key. If you hold down control and if you spin the wheel, you will be able to zoom in and zoom out. So it depends where your pointer is. So if it's on the pump, it zooms on the pump. If it's on the reservoir, it zooms on the reservoir. Okay? So The control key is a really important key into Automation Studio. You can do a lot of things by combining the control key and the few mouse buttons. I will explain them in a few minutes. Okay, so now if I'm just taking like more components, I'm just dragging and dropping components right now. So pressure relief valve and the pressure gauge just before, and then the double acting cylinder and a manually operated 4-3 directional valve. And then I'm going to show you how to connect those components. The first way to do it is by overlapping the components, like I just did right here. So if you want to connect the components, you can simply move those connection ports. Again, the connection ports to the red circle. Okay, so once it's connected, as you can see, it turns black. So once the connection ports are connected, it turns black. So now it means that if you're moving both components apart, it will create in between the two, it will create an hydraulic pressure line. Okay, so into which you can go into technical data and change all the properties. But by default, all the lines has a 20 millimeter as the internal diameter and a length of 100 millimeter. Okay, this is when you're using the software into a metric units. If you want to change the global settings of everything, you can go into Tools and then Options. Then under Application, under Options Application here, you can set the component units to be set into Imperial. If you do so, you hit Apply and Close, but then you will need to restart Automation Studio to take effect. So many of these options needs Automation Studio to restart, but everything that you had put onto the sheet already will stay as the unit that you had selected before. So it's only be for the new projects that you will be able to use the new unit. So you have to first change by going inside Tools, Options, and then Application under Component Unit. Once this is done, you close Automation Studio and you start a new project. And in this new project, every time you're going to drag and drop components, these components are going to be set into Imperial units. Okay, so now this one is connected already. Now what you can do is you can also go over one of these connection ports. It shows a little pointer looking like a ham right now. So once you have this icon showing, you can click once. Now you attach one side of the pressure line. If you want, you can switch direction by simply clicking once. I'm not holding my click, I'm just clicking once, and then I can switch direction. So I can switch direction as many times as I want. And once I have reached the end, I can see the same connector, the same pointer showing again, the same target. Once I do, if I click only once, now it attached the line. And I have the command that has been released right now. So the function is still not active, okay? It has been stopped. Now if you want to change the line appearance on a line that is already made, you can simply click once on the line, and then as you can see, it shows all the grips on the line. So you have the vertical grips, which will allow you to move from left to right, and you have horizontal grips, which allow you to move from up and down. And you also have the corner grips, which will allow you to move in two directions. Now, one good tip, as you can see right now, I'm connected into the return port of my directional pressure valve, directional valve. So if I want to disconnect the line without deleting the line, because I've seen this many times, and you do not want to disconnect the line. The only thing that you want to do is you want to disconnect one hand of the line. So you disconnect the line by selecting the line first, and then let me just zoom in a little bit, and then you hold down Shift. So you hold down Shift, you click on the line, then the line is disconnected. Now right now, if I release the mouse and release Shift, it disconnects the line. Okay, so the line is not attached at this side anymore, but the first port was still connected onto the pump. So you have this way of doing it, or if you want to disconnect like a quick connect, like you disconnect and you reconnect somewhere else, you do the same. So you move over to connector. As you can see, the pointer right now is indicating a small square with 4 arrows, so it means that I'm at the end of the pressure line. So I hold down Shift, I click once, now I'm disconnecting, and now I can simply reconnect directly to the other connection port. So I release the mouse and I release Shift, and now I'm connected to the other pressure port. okay, of the valve. So now if I move the valve a little bit, now it's perfectly straight line, and I'm able to continue my drawing right now. Okay, now how can I attach to this main pressure line? Well, there's two ways. There's the easy way and there's the long way. So the long way, I'm going to show you this one first because it's always good to know. If you go into layout, layout menu, and then you select break link, you can create any junction port wherever you want by simply clicking once. So you click once, and then it creates a junction port. As you can see, this one is still black. And because it's black, it means that I have a line that goes from here to here, and I have another piece of line that goes from here to here. Now, if you want to release this function, you simply have to right-click, or you can press down Escape on the keyboard as well. It does the same. So now I have two pieces of line. Now, both lines are at 100 millimeter length. So make sure if you do not want to have, if you do not want to head up length in terms of hoses length, you might want to make sure that all of these lines, if you do not want to have a junction between the two, you might want to make sure that these will not be separate, okay? Because it will add up the pressure drop at the end of the drawing. So this is not the case. I want to make sure that I'll be able to attach to this line. So what you can do is then you can start from this junction port, and then you can go and connect on the pressure relief valve. Now again, this is a long way to do it. Now the short way to do it, before I will show you, is really easy, but I will show you how to join the links. So if you had add up many lines and you just want to make all of those lines into once, you can simply select both lines that are at the end of each other, and once you have selected more than two lines that are joining, you can go into the layout menu, and then you'll have the join links function active. So you can simply click on join links, and now you'll be able to have only one line, which is going to be 100 millimeter in length, and then you have rebuilt one single line. Now, the easy way to attach is to start with a connector that is free. So this one is called free connector. And now if you're starting from there, I just click once when I've seen the aim. And then if I go into the pressure line and I double click, I'll be able to break the link and then directly attach to the line. Now if you're wondering here, I have a black dot. Okay, so this black dot means that I have more than 3 connections at the same point. Okay, so when you have a black dot, it indicates that you have more than 3 connections. And this can also be changed. So if I'm going now into hydraulic to take a reservoir, an atmospheric reservoir, because there's 2 differences between this one and this one. The differences are that if you look closely, this one has a paw that goes right into the bottom of the reservoir. And this is why we call it the hydrostatic reservoir, because if you double-click on the reservoir, you have an initial height and an initial volume. And this will make it to create a back pressure, okay? So a hydrostatic pressure, which will be the height of the fluid in the tank. And then for the other ones, if you double-click, you will see that there's no height listed or no really volume inside. So this one will perfectly will be a perfect return reservoir, so will not create any back pressure. So that's why I'm using 2 separate reservoirs. Now, if I want to connect this cylinder right here, what I can do is I can simply really quick overlap both connection ports, and then I'm ready to go. Okay, now, so if I zoom everything out, I just wanted to explain as well that you can also configure those settings for the black dot that you have there when you have a junction and when you have jumps. So if you go into the view menu and then into lines jump setting, now you can see that there's different options. All of these 3 different options are approved by the ISO standard. You have the way that we are using right now, which is when you have lines connecting, you have a black dot, and when you have lines crossing, you have a jump. We also have the line connecting that has no dot, and when you have lines crossing, there's a jump. And also line connecting with a dot and lines crossing without any. So we prefer to make it clear by using the last one, but again, it's really up to you. So if you decide to switch to this one, as you can see, it will automatically refresh everything and you won't see this black dot anymore. By the way, if you're going to print all this, I'm suggesting that you go into View and then that you remove the connection port before you actually get this to print, so it looks nicer this way, okay? So you won't see the connection port onto your diagram print. Now, if you print all this, it's not going to print the grid. So the grid is the one that will not and never show into a print, okay? Only the connection ports and the contact points and et cetera, et cetera. Okay, now I'm ready to launch this simulation. So I'll just zoom back in by using the zoom all components. And then if I launch this simulation, there's a few things that you can do during simulation. First one is to take actions on some of the valve and directional controls. So if you move over this directional valve right here, you can see that there's a little hand showing up. So when you have the hand showing up, you can click, and then you'll be able to activate some of the movements on the valve. Now, if you, depending on where you click, and depending on the valve configuration, right now this one has a spring return. So if I click and release my click, it's going to be set back into its initial position. This is all being done by the spring. Now, if you don't want to hold the valve all day, what you can do is you can simply click directly into one of the spool position, and then it's going to force the position. As you can see, there's a red big check mark, and once you have that, it means that the spool position has been forced. So you simply click once, and then it will maintain this position until you click on one of these commands. So only by clicking on the commands on the side, it will remove the force state of the valve, okay? So whatever spool you want to simulate, you can simply click directly on it, and then you'll be able to simulate that position. And then to reset the spool position, you can simply click on the valve, and it's going to be resetted. So there's also something else to do. If you right-click on components that are shown in red during simulation, except the lines, but all the components showing in red, if you right-click, you'll be able to see a cross-view animation of it, okay, into the corner right here. You can move this one around, but it's only one cross animation at a time, okay? So you can see all of these animations. Again, Automation Studio was first intended to be used as an educational tool, and that's why we maintain both versions of Automation Studio, the educational version and professional version. So the first intention of Automation Studio was, of course, to give a tool for students to understand hydraulics and pneumatics. So that's why we have those small animations for these students to understand what's going on in the circuit and how the components are looking like in a cross-view animation, okay? You can also click on different components where you have a little hand again showing up. When you have a little hand, it means you have an action that you can take during simulation. So you can dynamically increase the pressure, the cracking pressure on the valve. You can dynamically increase or reduce the displacement on the pump. And that's about it for this circuit, okay? So there's a few things that you can do. If I had an orifice in here, I'll be able to change the orifice size and et cetera, et cetera, et cetera. So there's a lot of parameters that can be changed dynamically. Now, one of the other great features that we have, if I stop the simulation by clicking on the stop button right here, is if you go into File and then Project Properties, there is the animated flow under Options, Fluid Simulation, and you can set the animated flow. So make sure that the flow that you have, the minimum flow that you have, will be great enough to compensate for this value here. Otherwise, you won't see any animation. Okay, so the default value is 6 liters per minute. So it apply and close. Now, if I launch this simulation, I'm also able to see some nice animation of not only the arrows of direction, but also some sort of a pattern that indicates where the flow is going at the moment. Okay, so again, it's really a good tool for demonstrating the way that the circuit should work. Okay, if I go at View, Lines Jump Settings, I'll just reset the lines connections back into normal. Okay, and that completes the first lesson. Then what I'm going to do is I'm going to try to speed things up. So I'm going to create another diagram but this time I'm going to create this diagram by using a few of the functions that we have for drawing. So I'll be able to directly insert components and show you really quickly what we can do here by using all of the Automation Studio potentials. Okay, so I'm just going to save this. Okay, and then I'm going to save this on my desktop, and then onto training, and I'll just create a new training folder. Okay, so this was a lesson B1-1. Save. Okay, and then I'm going to close this one and create a new project without using any template at the moment. Okay, so I'm not using any template. Click OK. Zoom out, and then I'm going to create a circuit right now, but I'll be using some pneumatics. Again, it's not a big difference in Automation Studio. For us, it's all the same. Specifically in the basic, the things are exactly the same for connecting and stuff, so it doesn't change anything for us. So I'm just going to, again, activate the grid and then drag and drop components in there. Okay, so I'm just going to drop a few components. Like this double acting cylinder, this pressure relief valve, and then into the different subcategories that we have under pneumatic. I'm going to get a little bit deeper into the workshop because this first level is the commonly used components. But if you go a little bit further, you'll be able to see some subcategories. And into these subcategories, we have also different levels. So if I'm going into directional valve, into the 5-2 valve, I'm going to insert the first one that I have right here, which is a normally closed directional valve. And then I'm going to complete the circuit. Okay, make sure that this one is straight aligned. You can also use the arrows on the keyboard as well. Okay, no problem. And then I'm going to connect this pressure relief valve on the main pressure line. Then quickly connect the cylinder, and then from the regular pneumatic route, I'm going to insert 2 exhausts. Okay, that's good. And now into Automation Studio, since we have this bare bone structure and those components into its proper location, what we're going to do is we're going to insert few of the different measuring instruments that we would like to show here. And when you're coming directly from the main library and you drag and drop component in there, it's going to automatically be attached on the line. So as you can see, it was automatically inserted on the line. And you can do the same here if you have a flow meter. You can directly drag and drop flow meters right in here. I'm not touching anything. If you're dragging and dropping components from the library, you can see under my pointer there's a small plus sign, and this means that it will automatically be attached on the line to anything that you're leaving the component on. So as soon as you have a connection port on one of those lines, it's going to directly be attached on the line. And it's the same if you have already these components and you want to move those components out. You can simply hold down Shift, and by holding down Shift, you grab the component by the left button of the mouse, and once you have these connecting, you can simply hold down Shift, release the button, and then release Shift, and then you'll be able to directly remove the component from the line. And it's the same. If you're into the schematic and if you want to insert this component on the line, you have to hold down Shift. If you do not hold down Shift, the component, as you can see, is not attached on the line. So if you move it, there's nothing moved now. As you can see, there's still red circles right here indicating that these connection ports are still free. And you have a line going across the component. So these are two great indications of the component not being attached to the line. So if you do hold down Shift, move your component over the line, release the mouse and release Shift, as you can see, it's attached on the line. Okay, it attached on the line. So if I'm going into the pneumatic right now and into the flow valve, I'm going to insert some restrictors with checks. Okay, so I'm going to insert some of these. Now, one of my tip is right here that if you are going to use one of these, make sure that you flip all of your components before you actually insert your component on the line. Okay, because if you do not put the component apart and then flip the component, if you do it on the line, you're going just to create a twist of all the lines right here. So before you actually insert the component on the line, I prefer using the component alone and then using those transformations right here, so left, right flip here, etc., etc. And then once the component is perfectly at the position that I want it, I simply have to take the component, I hold down Shift, and take the component on the line. Then release the mouse and release Shift, and as you can see right now, the component is attached on my line. Then if you want to take this component and take this component on the other side, again, by using the Control key, you are capable of copying components. So if you hold down Control and click on the component, you are capable of directly copying this component. As you can see, I still have a plus sign. So if I release the mouse and release Control, I duplicate my component, and I also inserted this component into my my pressure line right here. Okay, good. So now same thing here. If you want to launch the simulation, no problem. You simply have to launch the simulation. If you want to use a circuit, you simply have to click directly on the valve. Now this one has a solenoid. As you can see, there's a question mark. We're going to fill this one into the next exercise. So this one is indicating that right now it has not been assigned to any other solenoid, so that's why we have to manually shift the valve by overriding the valve by clicking directly into the spool position. Again, if you want to release that force state, you have to click in either commands that you have on the side. Okay? Good. It's the same here for the pneumatic. If you want to display those nice animation patterns, you can go into File, Project Properties, and then you can go into Animated Flow in Pneumatic, hit Apply and Close, and then you'll be able to see that nice animated flow in Pneumatic as well. Okay, and of course we'll have the animation of these components, so it's the same, okay, as all the other components. As long as they're showing in red, it means that you can actually change, it means that you can view the animation of these components. Okay, so I'm just going to save this one really quickly, and this one is going to be B4-1. Here we go, save. And now what I can do is I can simply, based on this exercise, so I'm going to save this one right now, save project as B42. Going to save this one right now, and I'm going to show you the different options that we have for manipulating components. Okay, so first I'm going to take all this, center everything. Okay, so I simply had to make a box around everything. It selects everything, or you can use the good old Control A. So Control A will also select everything, and then you can move things around. You can as well use the arrows on the keyboard. Once it's done, what you can do is, the exercise that I'm about to do is I want to make sure that all of these components will be pointing into the left. So if I select all of these components and then suddenly choose to make a left rotation, as you can see, it flips all the components individually, which is not what I want. So I'm just going to do Control Z. So if you want to flip all the components all in once, you have to group those components first. So make sure that you select the group button that you have right here. So you group everything. So once it's grouped, you flip. So now the center of rotation will still be into the middle of the group. So now I can move this group around. And now if I want to have the cylinder right now at about, I don't know, maybe a 60-degree angle, you can then ungroup. And then we have a function called a free rotation mode. So if you activate this here, free rotation, the corner grips showing squares right now, if you click here, the corner grips are going to show as round. So those circles, if you take one of them, you will be able to change the cylinder angle, okay, to whatever angle that you want. This, not to be confused with the actual simulation of the component. The component, if you double-click inside, is still at 0-degree angle, okay? So the inclination is still at 0. This is the only representation. This is only the representation of the component on the diagram, not the simulation of the component. If you want to change its inclination during simulation, for simulation, it has to be done here. So you double-click on the component and you access the technical data branch. And inside the technical data, you have all the parameters that are going to be used by the simulation engine. Okay, so not what you see on the diagram is not necessarily what is going to be simulated. Okay, so then this one is at a certain angle. Okay, good. If you would like to have something more into a specific angle, we have a function here. It's called the layout dialog, and under transform, you're able to change directly the angle of the cylinder. So if you want to change the inclination to exactly -60, then you click OK, and now I'm exactly at -60. Okay, so I'm at a 60-degree angle from this horizontal position. Okay, so you can do it freely by using the free rotation, or by using, if the component is active, by using the layout dialog, the last tab called transform. You can also change to get a precise angle on the diagram. Okay, so again, this is going really quick. There's a few of the different manipulations that you can do. So you can flip left, rotate right, vertical flip, and as well as horizontal flip. Okay, so basically mirror functions. Okay, mirror and rotation functions. Okay, so I'm going to save this one, and then I'm going to reopen the B4 one, because I'm going to do another exercise with this one. Okay, on this one, first I'm going to change my page orientation. Again, you right-click in the middle of the blank of the page. You choose Document Properties from the list. Once you have Document Properties, you select Landscape. You hit Apply, and then you close. Then once this is done, you will be ending up with a page into the landscape orientation. Now, what I want to do is I want to show you that if you have all of these components and you group all of these components, I'm going to duplicate them into my page, and I will I will make it random. Okay, so I will not try to align any of these, because I want to show you a function that we have into Automation Studio, and using this functionality, we'll be able to align everything and make sure that the gap between all of the groups will be perfectly identical. So what you can do is you can first select the first shape. As you can see, the first shape that you'll have selected is going to be switch in blue. And then if you hold down Shift, you'll be able to select the two other shapes. So you select the first shape, it's in blue, and then you hold down Shift, and you select the two other shapes by simply making click on the other shapes and still holding Control. Make sure you hold Control. And once you do, you have all your selection. Now, when the selection is done, you go into the Layout dialog, and then I'm going to use the Align tab, into which I'm going to use this icon here. So it's going to align all of the white group selected with the blue one. So this is what it means here. So with the first shape selected, you can also be relative to the page. I wanted to do it with the first shape selected, which is the one I have on the left here. So I click in here, click OK. So now all of my components are all level with the first component that I have selected here. Since this is done, I'm going back into the layout dialog, and then I will select the distribute tab, and I will select this one here. And by using this one, it's going to make the gap to be at equal distance into the selection of all the components that I have. So if I click here and then click OK, it's going to distribute the gap into all of these components. And now, since the gap is all the same, you can simply finish the diagram by stretching this one up onto the right. Take everything. Okay, zooming out a little bit, I'll just recenter. Oops, I'll just recenter everything. And once everything has been recentered, you can simply attach those to the line. As you can see right now, because the gap that I have used was not perfectly into a grid, what I can do is I can simply cheat a little bit, and maybe I can simply move this one to the next connecting grips, and voila, this is completed. Now, if you launch this simulation, all of those three are going to work and be connected. So it goes really easy and really fast to complete diagrams, especially if you have blocks that are really quite the same. You can simply duplicate those blocks into the page. Okay, so that completes the lesson. So I'm going to save this one now as B43. And I'm going to close this one and reopen B41, because we're going to use this one for creating variable assignment. So remember that I have said that this guy over here, it has a small question mark indicating that it's not assigned yet. So what we're going to do is we're going to use the electrical control JIC standard. So sorry for the ones that are from Europe right now. We're going to use the American standard JIC control. It's really basic, so I don't think it will get really complicated. So we're just going to insert two components, okay, which is the power supply and the common. And then once I have those two components, I create a line in between the two to join the two together. And once it's done, I'm going to insert directly into the line. So I'm just creating my bare bones structure right now, and now I'm inserting directly my components. So I simply have to drag and drop components on my previously created line. So right now the software asks me to enter a tag name. Okay, so it's going to be its identifier. So I'm going to name this solenoid. I'm going to name it EXT for extension. And then I'll click OK. So make sure that you give a name when you're prompted to give a name, because otherwise it takes a while to go back in there. So let's say if I didn't input the EXT right away, you have to then double-click on the component, access its variable assignment, click on the line where you have the variable assignment, and then click on Modify, then change the name, then OK, apply, etc., etc. So as you can see, it goes really faster if you directly input the name when you're prompted to input one. So now, right now, this one is still, I call it an orphan, because right now you have the child and you have the parent right here. So I'm going to link this child to his parent. So as you can see, if you double-click under the variable assignment branch inside the component, you will see that you have, in the list, you have the variable assignment of the component, which is the question mark. When it says read here, you cannot actually change this value. So if you try to input a name right here, it doesn't go. So you absolutely need to select the variable from the list that you have at the bottom when it says read. So it's going to read from his parent row. So you select EXT. Then if you want to save one step, instead of clicking on link and then clicking on apply and close, you can simply click on apply right away. And as long as you can see EXT right here, then you can click on close, no more questions asked, and as you can see, right now, the link has been done between this solenoid and this solenoid. Because in Automation Studio and in all the fluid power diagram, you will never see wires coming out of those solenoids into the valve itself. So that's why into Automation Studio we have, because we're capable of communicating between workshops, that's why we have to use some variables to make sure that one will respond to the other. So if you launch this simulation right now, you will be able to see that now I have the solenoid here, which is not activated. I have some power coming in here, and I have this grounded. So if I click here to join the links, as you can see, it will close the connection, activate the extension, and then if you want to hold down on the push button, because if you just click once, there's a spring and return inserted in that push button. So if you're not holding down the push button, it's going to return all the time. If you want to hold it down, you click once, you hold your click, you move away. When you do not see the hand again, you release your click and the button stays pushed down, okay? So right now I'm controlling the directional valve that I have here by using the push button. And of course, if I want to change the speed that I have on these meter in, meter out unit, I can simply increase those diameters, and now I should be able to have something that goes quicker. Okay, again, this was the first lesson for introducing you to what we call a variable assignment. We're going to make another lesson on this just quickly using ladder logic. Again, this is more for control circuit. And once we'll have that completed, we will be able to get into simulation testing and analysis. So I'm going to save this right now, save project as, and then this is going to be B51. Okay, and then I'm going to save this as, again, B52. So I'm reusing the same project right now. Okay. Now, what I'm going to do is I'm going to insert into here some sensors, some proximity sensors. So this way I will be able to verify what's the position of my cylinder. So first I'm going to insert a proximity sensor that I'm going to call in, and then another one that I'm going to call out. So the proximity sensors, you have some directly into the root of pneumatic or hydraulic, or you also have some, if you go into deeper pneumatic or hydraulic under sensors, you also have a great selection of all the different sensors that we have into Automation Studio. So right now I have in and out. Now these sensors, they are also using variables because there's no wires that are connected anywhere. So we're using not a variable, but this time we're using what we call a contact point, almost acting like a variable. You can't see anything, so what we're going to do is we're simply going to overlap those diamonds. So you have diamonds on the piston on each side, and you have a diamond at the end of the rod. So by using those diamonds, I'm going to use the ones on the side of the piston right now. And by using those diamonds, you simply have to overlap those diamonds. And as long as they overlap, they will be activated. So when the piston is going to touch those contact points, it's going to activate the sensor. But for the one that we have at the end here, if we want to make sure that we will be able to activate this one of my tips is to go into technical data, and then you change the extension to 100%. You hit apply, and then you close. And now once the cylinder is fully extended, if we want to make sure that this one will be overlapping, we simply have to move and make sure that these diamonds, so the diamonds that you have on the proximity sensor and on the piston, these will overlap, okay? And then once this is done, you reset this one back to 0. So under the technical data, when you double-click on a cylinder, the extension needs to be set back to 0. Hit apply and close, and now the operative part is completed. What I can do is the control part. Okay, so I'm not going to do the long exercise that implicates some ladder logic and everything. I just wanted to make it quick. So what I will do is I'm just going to use the electrical diagram. Oops, sorry, I just opened up the catalog. Okay, so into the Library Explorer, I'm going again to select the electrical control, JIC standard, the same. And right now, I'm going to insert some normally open proximity switch. Okay, and then I'm just going to change this a little bit. Okay, so I need to launch the sequence. I need this. There we go. And then I am going to need a latching coil. So this is going to be for C1, so coil number 1. So once I'll have this, it will close, and then it will set the coil. And this coil, I'm going to insert a contact. So I'm just going to complete another row here. Going to insert a contact. And this contact is actually going to activate the coil, the solenoid, sorry. So this is related to C1. And now the only thing that is going to make the whole thing reset is that when this proximity sensor, so let me just take a reset coil. Okay, so this reset coil is going to be activated by the contact that I have here. Oops, hold down shift. Make sure to never forget to hold down shift. And this one is going to be linked with out. So this one is out, and this one is in. So you hit apply and close. So now we have in. That is going to activate the setting coil. Once this coil is activated, this is going to start up the solenoid. So the solenoid will kick in. Then it will make the cylinder to extend until it reaches out, which is going to reset the coil number 1. And then it's going to go on and on for forever. So if you launch the simulation right now, there we go. And then you got a continuous movement. And now the only thing that you can do right now is to play a bit with the parameters. So if you want to slow things down or whatever, you can simply click on the orifices that you have there and then change the meter in and the meter out. Okay, now since we have something fully automated, we can now focus on the data that we have into the diagram. So I'm just going to zoom everything here, save this as B52, and then I'm going to resave as B61. So again, I'm just doing this just to keep track of all of my exercise, and as well as because I'm following the basic exercise that we have as the usual 3-day training kit. So what I'm doing is I'm simply following those exercises really quickly. Usually we give time to participants to actually do the exercise, but right now it's just a presentation. So this is just to make you kick-started on Automation Studio. So what I have right now is this circuit, and by having this circuit, I might want to have a look maybe on the pressure or on the cylinder speed. So what I can do is I can simply open up what we call a plotter. So it's this icon right here. So if you click, it opens up a window with a lot of grid. And in the grid, what you have is nothing at the moment. So what we're going to do is we're going to make it, I'll just want to stretch this one a little bit. And what we can do is to get parameters out of it. So to be able to read data, what we can do is we can simply drag and drop components. So maybe if we start with the cylinder, we can drag and drop the cylinder. And we can have maybe its linear position, and why not its linear speed. So you simply have to click which parameter that you want to see in there. Then you click OK. And then once you have those parameters inserted in there, there's default scaling factors that we have inserted here. So default scale. As you can see, they all have their own colors. So I have the blue here for the pale blue, and I have a green bright green for the speed. So depending on the units that you want to use, so right now I know that the default stroke of the cylinder is 250. So I'm just going to double click in this cell and change this to 250 millimeters. So now if I launch this simulation, I'll be able to see those parameters going on and on. Okay. And now if I move over one of these curves, I can also see the value at 1 particle at a time. And now what happened is because the time scale is set to 10 seconds, so I have a window width of 10 seconds. So if I pause the simulation right now, you can see that the window width goes from 12.9 to 22.9. This can be increased to 60 seconds, but everything that has been done since the beginning is still in there. So you keep everything. You're not losing anything. It's just that at all time, the window width that you can see is 10 seconds. But again, you can increase that number up to 60 seconds. So once you have those values, well, by the way, you can, I was just trying to do one or two, but you can simply drag and drop any components. And worst case scenario that you might get is if you drag and drop a component, you might not have any plot for this component. So don't be shy, just drag and drop components in there, and then you'll be able to plot as many as parameters as you want. So when you launch this simulation, you'll be able to track all of those parameters and keep a trace of all the data that you had during simulation. So if you stop the simulation, once the simulation is stopped, as you can see, all the data are kept into the plotter. What you can do is you can go into the plotter itself, and then you can select which parameters that you want. And once, by holding down Control, and once those parameters are selected, there's a button highlighted here called Export. So you can directly go and click on Export, and then you can select those parameters and save all of these parameters into what we call a tabulated text file. So if you go here, and then I save these as plots, okay, plots 1, and then I save. So it goes really quick. It's a tabulated text file. And now, if you don't know exactly what tabulated text file look like, so if I'm going into training here, then training, plots. So into here you have different columns that are all written right here with the scale that you had at the during the simulation period, and all of these values are listed into different rows. So the easiest way to work with these, if you're not familiar with these kind of files, you go into Microsoft Excel or any other workbook. You take this, you open it up inside File, Open, then you select the files type of text files, and of course into where you have saved your file, you click on Open. It will ask you what is delimiting the file, so you can simply select that as the tab, and then you click on Finish, and then you'll have all of these values done into separate columns. You select all of it, and then you hit into the here, the graph, you hit these with the lines, and then it automatically reproduce the graph that you had. So if you want to have a specific value at a specific time, you can keep track of all your data into a separate file. Okay. Into Automation Studio, it's also possible to create something like this. It's just not as flexible as it is if you are exporting the values into a text file. So if you just click on Cancel for this, okay, and then if you go into Automation Studio, you can as well right-click and choose Copy Image. So you can save the image of the plotter as it is right now, and it will show all the scales and everything. Or what you can do is you can also create a plot file if you were using the dynamic measuring instruments. Okay, but this is part of another lesson. Just really quickly, we also have dynamic measuring instruments that you can use here, and then you can get any values, pressure, specific mass, temperature, viscosity of the fluid, and then you apply, and when you launch this simulation, you will have that information showing, And if you record that information, so if you right-click and record that information, once you stop and you have this recording, you can save those simulation values. And this will create into a measures folder, okay, subfolder in your project. It will create a plot file. So if you double-click, you will be able to see the value directly into a plot file. Okay, so it keeps the plots directly into Automation Studio. Okay, but again, this is in a separate lesson that we might do in a few other webinars. If you never had the chance to see or follow a training on Automation Studio, full training, usually the Automation Studio basic and intermediate training is based on 3 days. So right now I just have given a part of the basic training. Maybe just to end up and close the session for today, before the question period, what we're going to do is we're going to see the different simulation mode and type. Since the beginning, I just clicked on the green button right here. So this is what we call a normal simulation. So when you launch the normal simulation, you have a time here. Okay, so this is the simulation time. And this simulation time is really close to what you have on your watch right now. Why? It's because the computer that I have right now is a good computer. And also, this is a kind of small circuit. So everything is done dynamically. The refreshment is done quite nicely. So the seconds that you have here are really corresponding to the time that you have on your watch. Now, if you had a greater diagram or poor computer, what will happen is this time might be a little bit slower than what you have on your watch. So if you have a large diagram or a really poor computer speed, what you get here is a time that will be slower than the usual. Okay, that will not be as close as what you have on your watch. Okay, so if the cylinder should extend in 4 seconds, it might not be 4 seconds on your watch. It's going to be 4 seconds that you have right here. Okay, so make sure that you never confuse the time that you have on your watch and the time that is displayed into Automation Studio. Many times this time will match, but it could happen that it's not matching, specifically if your computer is not great enough or if your schematic is really large. When I'm talking large, I'm talking about like C format with full of components, or D format size and full of component, or if you're more familiar with ISO sizes, I might talk about like A2 or A3 size of diagrams. Okay. Okay, so if I stop the simulation, which I did, now we're going to talk about the step-by-step simulation. So the normal is as close as possible to what you have on your watch. Then we have the step-by-step simulation. So in the step-by-step simulation, the time is stopped at every step during the simulation. So into Automation Studio, we are doing about 100s of calculation per second. Okay, so we're doing 100s of calculation per second, but because of the refreshing rate of and refreshing everything dynamically on the screen, what happened is we're only displaying 1/10 of a second. So what we're doing is we're doing 10 calculations. So the simulation engine makes 10 iterations, and once it's completed, we display the average of those 10, and then we do another 10 and then display the average. So every time you see a step, it's actually 10 steps of simulation that you can see. Okay, so every time you click right now, you will see about 0.1 second time increasement. Okay, so right now this is quite good if you want to do some explanation step by step on how the system is working. So right now it has reached the end. Okay, as you can see, it has reached out. This has been highlighted. Now the next step is this guy is going to reset the coil, which it just did. And then the next step is the valve is going to be shifted back into its initial position, and now the cylinder is retracting until it touches the next proximity sensor, which is going to be reactivated here, which is going to highlight the coil, etc., etc., etc. Then you can go as well to switch dynamically again to the slow motion simulation. So this is basically the same as the regular simulation. It's just that this one goes 5 times slower. Then you also have a button for pausing the simulation. So this just pauses simulation. And of course, you have the button to stop the simulation. But at any time, you can switch between those modes, no problem. Okay, and now we have something else. It's the different types of simulation. Since the beginning, we're using the simulate the document. But if I create a new diagram, so File, New Diagram, or I can simply click on this icon right here, New Diagram, without any template, click OK. What I can do is I can simply take, let me display all of these into vertical tiles. I can simply take this is another sheet. I can simply take all of this, so it selected everything, and I can bring this into another diagram. And now I can display them side by side, okay, into 2 different diagrams. There we go. And now if I launch this simulation, because this one is not simulated at the moment, I cannot have the movement of my system. So what I'll have to do is I'll have to switch to the entire project. So now if I simulate the entire project, I'll be able to have all of those diagrams running at the same time. Okay, and now what you can do is you can also create another diagram. Okay, and into this third diagram, it's going to close those right now, and then vertical tile. And then into this diagram, I can decide to have this part. I can right-click and convert my link to jump. So I can convert those links to jump directly. And then I can take all of these into a separate diagram. So now if I simulate the entire project, I'll be able to have all of these diagrams running. So I have the operative part, I have the actuator into a separate diagram, and I have the control part into another diagram. Now, if you want, you can also switch to simulate the selection. So maybe if I take this back here, okay, and maybe if you had something here that is not complete, but you do not want to use the CPU processing time for simulating something that you do not want. So right now this one is simulating. So maybe you do not want to simulate this if it's not necessary. So what you can do is you can go here to select the items to simulate. You can say, I don't want to simulate the diagram number 3. So you simply click on 1 and 2. You hit OK, and now when you launch the simulation, oh, sorry, I forgot to switch to the simulate selection mode. Then when you launch the simulation, you only have those 2 diagrams running. So this one will stand still. So you're not using that precious CPU processing time if you do not want to simulate a circuit that is not completed. Okay, well that completes the today's training. Again, there's a lot of more functionalities to see and everything, but this is the introduction presentation. So I'm guessing that this should be able to at least get you kick-started on the software. Now, if you have any questions, I hope you had noted your questions. I can give you the possibly to speak to all the others if you want. So if I go into options, you can raise your hand, or you can, if you have any questions, just let me know, and then I'll be pleased to answer all of your questions. So I can see there's a few questions right now. Let me stretch here. Okay, we have a question for Michael Schultz. Is there anywhere where we can see a more detailed explanation of the component used in the Library Explorer? There is a guide into the CD, actually, into the Automation Studio CD. In this CD, you can actually see the different guides, and there's a guide in particular that I'm thinking of, and this guide is called Fluid Power Guide. So I don't know exactly if this fulfills your questions. Let me just pop in. I have the Automation Studio DVD right here, and let me just open it up. Okay, so I'm just going to insert the DVD into to the computer. So when you first launch the DVD, you get this message here. So if you run the autoplay, there's a section called User Guide. Okay, and then into User's Guide, you have the, of course, all the guides, and one that is explaining a lot of things about the component is the fluid guide. So if I open it up, the fluid guide here. So this is the hydraulic and pneumatic workshop user guide, and into this guide you have more information concerning the components. So how you might want to use some of the components, how to create different installation and circuits, how to manage the fluids, and as far as the components are concerned, you have the explanation of some components. Okay, so we have the explanation of these components, major simulation options for fluid dashboards, etc., etc. And then you have the hydraulic simulation options. And there's few other things that we explain, specifically if we had made some changes into the new versions. We will all put this into the guide. You have the section 4, which is the component description, and into that section we have given more explanations on the component itself. And at any time, if you are wondering like how a component works, if I'm going back to Automation Studio right now, if you're wondering how a component works, you can simply click on a component, and then if you hit F1, it will open up the help file into which you can see how it operates and what's the main purpose of pressure relief valve. And then you can see under the technical data all the explanations of all the different parameters that you can find into the component itself. So this usually becomes really handy if you're wondering how a valve is working or anything. So we have these explanations for almost all the components. Okay, any other questions at the moment? We still have plenty of time, no problem. So if you have any questions, just raise your hand. And again, I'll be pleased to answer. I'm again still waiting for some questions. Okay, looks like we have another one right now. I think it's the response from Mr. Schultz. Okay. Can you hotkey keystroke to switches in electrical circuit? The answer is no, not at the moment, but into version 6, we are planning on using some scripts, and by using those scripts, you will be able to launch any commands, or you will be able to launch any functionalities. So this might be something possible into version 6. You might be able to assign hotkeys for clicking on the valve. One thing that you might be interested in is into Automation Studio, we also have if you have the proportional hydraulic or proportional pneumatic, into the set point devices, there's a game controller that we have. So if you have any USB control device for, let's say, for gaming, you can take any of these and bring it into Automation Studio, and then under configuration, if the driver is recognized by window, you will be able to see here the driver listed, and then when you select the component, you will be able to see all the variables. So you will be able to use those variables. So if you have buttons, like on a gamepad, this is looking like a gamepad, you will be able to use all of these buttons. And this is what we're doing here at Famic. We have like few wireless joysticks that we're connecting to or PCs, and instead of trying to click onto one joystick at a time, we can manipulate using our two hands with all the buttons. We can actually reproduce a virtual machine by using those gamer joysticks. So if you have any USB device that you might want to connect here, again, as long as it's recognized by Windows, you will be able to see those variables, to see those parameters. So all the joystick and the buttons will be shown here, and then you can enable them to see them into your entire project, and then it can be assigned to anything later on. So if it's a Boolean, it's going to be able to be assigned to a switch. So this is probably the easiest way to assign the hotkey if you have a gamer joystick pad or something. Okay, another question? Yes, it can also be assigned to push buttons. So the question is kind of the continuation of the other question. He's asking if you can also assign these to push buttons. Yes, it can be assigned to push button or switches. And the next question is, can see fluid filling cylinder while extending or retracting? Actually, yes, you can. You cannot see exactly the fluid. Maybe if I reopen the diagram, the project 1.1, the only thing that you can see is you can actually see the fluid by launching the simulation, and then when you click, you can see the fluid going there. You do not have any idea how much fluid, but what you can do is you can go into the hydraulic and then measuring instruments, and inside measuring instruments, you can insert an integrating flow meter. And now you will be able to see exactly how much fluid. So what's the volume of fluid going inside the cylinder? So this is when it goes in, this is when it goes out. Sometimes it has a little difference between the two because it depends of the leaks and it depends of when exactly the volume has been taken. So it's not exactly perfect as in terms of precision, but it will give you a good idea of how much fluid is going in and how much fluid is going out. You can also see that if you want to open up into the library, you can open libraries that are coming standard with the version. So I'm just going to close it now. You can open up the Library Explorer, and into the Library Explorer, if you click on the Open Book, it's going to open up the library, and into the default Automation Studio 5.7 libraries, you have something that we call the cross-section views, and this is available for everyone. So if you have the version installed, no problem. You select cross-section views, and then you hit Open. So this is going to open up the cross-view sections. So basically what we have done is we have recreate all the animations. You know the animations that I have shown you when you were simulating on the red component? If you right-click, you have an animation. So this animation has been recreated into separate animations. So if you want, you can simply drag and drop components, and those components are animated cross-view, but they can be set and they can be put anywhere. So if you drag and drop these components, you can simply double-click on the component, and then under the Component Association branch, you will be able to select the compatible components, and then you can see how much pressure and flow and speed and everything that goes in. Everything is scaled. So if you can click on Apply and Close right now, now you just link this cross-view animation with this cylinder here. So you will be able to actually see what's going on inside the cylinder while you're extending and retracting. So this can also be good information of what's inside the cylinder. You can also, if you have the HMI control panel, there is also boxes that you can use for displaying like view meters. You can use them, like numeric display boxes. So you can use them, And inside of those boxes, you can say, let's say, volume. And this could be in cubic meter, whatever. Hit apply, and then inside internal links, you can set variables and see directly the value. So if I take here builder, I know that we can directly see the linear position. So maybe this one is 500 millimeters. So I can change into sensor here from 0 to 500. And right now, I will be able to directly see the position in millimeters. So if I change this to position, hit apply, and then I'm going to link this to the position, hit apply and close. So now at any time, I can see what's the position of my cylinder, okay? And this is really precise, because right now I'm transducing the actual position of the cylinder in a signal, and I'm changing the signal to be displayed into this box here. So what I see is the actual position. So if I change this to something smaller, so we'll be able to see something. So now you can see really the position of the cylinder millimeter per millimeter. Okay, really helpful. Okay, any other questions right now? I do not have for as far as the counter for electrical. So Mr. Schultz is also asking if we have any electrical counters to count the number of times that an event has occurred. I'm not sure if we do have them. I will say no, but what I will do, Mr. Schultz, is I will answer this question by email, and I will refer you to one of my colleagues that is more specialized into electrical components. Okay, Mr. Paba has raised his hand, so I will simply let him speak if he wants to. So I will unmute you, Mr. Paba Ravi Kumar. So if you want, you can speak right now and ask your questions to all the others. I cannot hear you. I can hear my voice through your speaker, but I cannot hear you. Do you have any mic, or do you want to ask the question directly using the question panel?
Can you hear me?
Yes, I can hear you. Everyone can hear you.
Yeah. Can I get this default components from any of your websites? But I want a default valve of like high pressure valve of some Linde manufacturer. Can I get the data from anywhere of your library?
What you're talking about is that the cross-section view?
Yeah, not cross-section view. Even the component.
No, you're talking about specific components?
Yeah, the specific components.
Okay, specific components, these are all done into the catalog. So we have catalogs right now, and if I open up a catalog, let me show you. We have already a few catalogs that have been released, and for accessing those catalogs, you have to actually get a membership for 1 year. I don't know all the details, but I know that, so we have different catalogs at the moment. We have Delta Power, Eaton Pumps. I'll just mute you for a second. Okay, so we have a Delta Power, we have Eaton Pumps, Eaton Valves, Hydroforce, Sun Hydraulics, and Automation Studio catalog that contains few other manufacturers. So let's say if I open up Hydroforce, okay, so there's the agreement here. Okay, so this is the Hydroforce catalog. And the catalog is exactly the same as the library. It's just that it has more features. Okay, so into this one, you can also make some search. So let's say if I'm looking for a valve called SV something, I just put SV and then star, and then I can start searching for this valve, and then I might have a few results. So let's say if SV08 was the one that I was looking for, you already have this component. You also have the detailed information of the component, such as its cavity, the fluid that is compatible with, maximum, minimum temperature and pressures. And then you have the pictures of the component that you can directly load up by double-clicking on it. You also have the manufacturer's specs. So you have the PDF linked with this valve as well. So it appears on my other screen here. So you have the PDF of the valve itself. And then you have a few notes and accessories if you have accessories that comes with. Now, if you want, you can directly replace this valve into the schematic by the component coming from this here. So all the components are already pre-built. You have inside all of the specific information that will be exactly matching the manufacturer's specification. So into here, you also have the documents, and inside documents, you also have the test bench. So if you click on documents, it's going to open up the PRX file. And this PRX file is actually a test bench, a virtual test bench of the components. So it's loading the test bench right now. Oh, I'm sorry, it's opening up the version 6. So I'm sorry. I'll have to, yeah, I cannot open it. I'm sorry. It's because I have the version 6 beta installed already, so it tries to open up the version 6. So I cannot really open this one, but it's a file and it contains a test bench. So it's virtually bench testing the component to make sure that it matches what the manufacturer said it was doing. So by using those catalog information and catalog manufacturer's component, if you have a green check mark like these ones here, these were approved by the manufacturers. So basically what we do is we prepare all of that information. We prepare the catalog here at Famic. We prepare the test bench as well. We test the component and we tweak the component as most as we can. And once this is done, we send all of that information to the manufacturer itself. And the manufacturer is also Home Automation Studio. He tries this component and he bench tests the component into Automation Studio, and if it matches the real test bench values, it approves the component, send us back all that information, and then we publish the component into Automation Studio into the catalogs. So into those catalogs, many of the when we release a catalog, I think we're expecting a minimum of 80% of the catalog being approved. And some of the components might be still pending. So if you see like orange icon on the side of the component, it means that it has not been final approved. All the ones that has a green check mark, it means that they were final approved. Okay, so almost all of the components were approved. Some of them might not be final, but almost all of them. So we have different catalogs here into Famic, and this is working as a membership. So we're actually selling this as a membership. I think right now there's a promotion, and if you want to get your hands on this, I think if you already have the annual maintenance, I think you can get those for 6 months, and then we will start the membership or something. So you might try to get more information to your sales rep about that, because I am not into the sales rep. I'm more into the technical side. So if you need more information, you simply have to ask your sales representative. Okay. Any other questions? There's Michael here asking another question. Will you continue to offer web-based seminar to this one in a more advanced format? The answer is yes. This is one of the, we have done few seminars in the past. Usually we try to do some seminars in specific topics. This one is a really, really popular one, since this one is the basic. So with the introduction webinar is one of the series of webinar that we want to do, and of course in the future we will have more and more of those webinars, especially into advanced features like pump builder, manufacturers, pump builders, catalogs, one specific ones on catalogs, and into the new directional valve models, and into troubleshooting, because the version 6 will have troubleshooting as well, and of course more and more functionalities that will go on with the years. Yes, this is just the beginning of a series of components that we're not components, but webinars that we're planning on doing into the next few years. Any other questions? Again, we have done some of these seminars in the past years. They were not really popular, and we had a problem with the tool. I think now the tool from GoToMeeting, we're using GoToMeeting, GoToWebinar. I think it has been approved, and we're mastering the tool as well. So I think we'll be able to provide more support, direct support through those webinars to our customers. No problem. Okay. Any other questions? Again, we still have 2 minutes, so if you want to ask your questions, it's now or next week. So whenever you want. Again, we will be organizing the next seminars. We're planning on having one every Tuesday. The next one, again, is going to be next Tuesday. Those webinars will be mostly intended for the introduction, of course, at the beginning, but then what we're planning on doing is maybe we'll do one introduction webinars per month, and then for the other weeks we'll have another topic. And of course, these webinars will be also published on a website. Right now, everything that we've done today was recorded. So I'm probably going to publish this webinar right after we close the webinar, and this is going to be available to everyone. So if you want to review the webinar that we have done today, it will be up to you, no problem. Okay, so if you have any other questions, just let me know, because I'm going to end the webinar in a few seconds, since I have no more other questions. Okay, so I couldn't see any other questions at the moment. So if you do have no more questions, I'm going to end up the webinar. Looks like no more questions. Okay, good. I hope you all enjoyed the presentation. Again, it's just a small part of the big monster of Automation Studio. This was just for giving you a kickstart if you're familiar or if you have not worked with Automation Studio since a few months. So this was just to giving you the interest and try to enjoy the software as much as possible, optimize your performance and drawing capabilities with Automation Studio. So thank you for watching. Again, I hope you enjoy, and if you ever ask any questions that I was not able to answer, I will contact you by mail. And if you want to participate to the next webinar, again, you're welcome to subscribe to the next one, again, happening at the same time on next Tuesday from 1 week from now. Okay? So have a good day, and see you later.